August 15, 1940, RAF Manston, Kent, 1:47 p.m. The Air Ministry inspectors stopped counting at Aircraft 23, overwhelmed by the sheer volume of Spitfires returning from combat with battle damage that would have destroyed lesser aircraft. Wing Commander Cecil Boucher, station commander at Manston and former skeptic of monoplane fighters, stood on the tarmac watching pilots climb from cockpits of machines that Air Ministry procurement boards had dismissed 7 years earlier as too radical, too expensive, and too fragile for operational service. Across the airfield, ground crews swarmed over Spitfires perforated by cannon fire, their elliptical wings shredded by bullets, yet still flyable after dogfights at altitudes and speeds that biplane advocates had insisted were impossible. What Boucher didn't know was that he was witnessing the vindication of a designer Air Ministry officials had mocked as an impractical dreamer, a man who had spent 15 years perfecting an aircraft that became the only reason Britain survived the summer of 1940. The Supermarine Spitfire, a fighter Air Ministry engineers had called a racer unsuitable for military operations. But between 1936 and 1940, Reginald Mitchell and the Supermarine design team created something that shouldn't have been possible. A fighter so aerodynamically advanced, so perfectly balanced between speed and maneuverability, and so structurally robust despite the delicate appearance that it outperformed every contemporary fighter while remaining controllable by average pilots. And in the skies over southern England during the summer of 1940, the aircraft that procurement officers had nearly rejected became the weapon that prevented German air superiority and saved Britain from invasion. For 15 minutes of combat endurance at maximum power, a Spitfire pilot possessed advantages German fighter pilots couldn't match. That margin, multiplied across 600 aircraft, changed history. The story begins not with the Spitfire, but with a seaplane that won a trophy and changed British aviation forever. September 1931, the Solent near Southampton. Supermarine Aviation Works, a small seaplane manufacturer, had just won the Schneider Trophy for the third consecutive time with the S-6B, a racing seaplane achieving 407 miles per hour, faster than any aircraft in existence. The victory was celebrated briefly, then forgotten as economic depression forced British aviation companies to focus on survival rather than innovation. But Reginald Mitchell, Supermarine's chief designer, recognized something Air Ministry officials missed. The S-6B represented a revolution in aircraft design that made conventional biplane fighters obsolete. Mitchell, a 40-year-old engineer who had designed seaplanes for 15 years, understood that speed depended on reducing drag. The S-6B achieved its record-breaking velocity through streamlining every surface, eliminating unnecessary protrusions, and minimizing frontal area. The same principles applied to fighter aircraft. A monoplane with retractable landing gear, enclosed cockpit, and streamlined cowling would be faster than any biplane, fast enough to intercept bombers before they reached targets, fast enough to escape when outnumbered. But British military doctrine in 1931 remained committed to biplane fighters. The RAF flew Hawker Furies and Bristol Bulldogs, open cockpit biplanes with fixed landing gear, maximum speeds around 200 miles per hour. Air Ministry specifications for new fighters prioritized maneuverability over speed, assuming future air combat would resemble Great War dogfights, tight turning battles at low altitude where biplane agility provided a decisive advantage. Mitchell drafted preliminary designs for a monoplane fighter in 1932. The concept appeared radical. A low-wing monoplane with retractable landing gear, enclosed cockpit, and 8 machine guns concentrated in the wings. The estimated top speed exceeded 300 miles per hour. The design promised performance far exceeding that of any existing fighter. Mitchell submitted proposals to the Air Ministry. The response was dismissive. Air Ministry engineers noted that monoplanes were structurally weaker than biplanes, particularly in high-G maneuvers. The proposed retractable landing gear added mechanical complexity that would increase maintenance requirements and reduce operational availability. 8 wing-mounted machine guns seemed excessive. 4 guns provided adequate firepower, and concentrating weapons in the wings made harmonization difficult. The entire concept, one review stated, represents theoretical performance advantages offset by practical operational disadvantages. But Mitchell had an ally, RAF Commander Hugh Dowding, who would later command Fighter Command during the Battle of Britain. Dowding recognized that bomber speeds were increasing. The new generation of monoplane bombers under development, fast, heavily armed aircraft capable of 250 miles per hour, outran biplane fighters. Intercepting modern bombers required fighters equally fast, and monoplane designs offered the only path to achieving the necessary performance. In 1934, the Air Ministry reluctantly issued Specification F-3734, requesting designs for a monoplane fighter armed with 8 machine guns. Multiple manufacturers submitted proposals. Mitchell's design, designated Type 300, was the most aggressive: elliptical wings for optimal lift distribution, a Rolls-Royce PV-12 engine producing over 1,000 horsepower, and a structure that prioritized speed while maintaining structural strength for combat maneuvers. The prototype that emerged in 1936 looked nothing like existing fighters. The Supermarine Type 300, later named Spitfire, possessed lines that seemed too delicate for military service. The fuselage was narrow, barely wide enough to accommodate the pilot. The wings were thin, their distinctive elliptical shape creating an appearance of fragility. The entire aircraft weighed 5,280 pounds loaded, light compared to contemporary designs, but achieved through stressed skin aluminum construction that distributed loads across the entire structure rather than relying on internal framework. The engine was the Rolls-Royce Merlin, a V12 producing 1,030 horsepower. The Merlin represented British engineering at its finest: sophisticated metallurgy, precision manufacturing, and reliability under sustained maximum power operation. But it was expensive. Each Merlin cost more than some complete aircraft. Procurement officers questioned whether Britain could afford fighters requiring such costly engines. The armament was unprecedented. 8 Browning .303 machine guns, 4 in each wing, synchronized to converge fire at 250 yards. Total ammunition capacity was 2,660 rounds, providing approximately 15 seconds of sustained fire. The concentration of firepower represented Mitchell's philosophy that future air combat would be decided in seconds. One burst from 8 machine guns delivering 160 rounds per second would destroy any bomber or disable any fighter. Test flights in March 1936 revealed both extraordinary capabilities and concerning limitations. Maximum speed reached 349 miles per hour at 16,800 feet, faster than any fighter in RAF service by over 100 miles per hour. Rate of climb exceeded 2,500 feet per minute. Handling was light and responsive, the controls remaining effective even at maximum speed, where biplane control surfaces locked up. But the aircraft was difficult to land. The narrow track of the retractable landing gear made ground handling tricky. The high wing loading, weight divided by wing area, required higher approach speeds than pilots accustomed to biplanes found comfortable. Several test pilots reported that the Spitfire was a high-performance aircraft requiring above-average piloting skills. Air Ministry procurement boards reviewed test data and concluded the Spitfire represented excessive capability for questionable operational benefit. The aircraft was too fast. Pilots couldn't maintain formation at cruising speeds without throttling back significantly. It was too specialized. optimized for high-altitude interception but less effective at low altitude, where most combat occurred. And it was too expensive. At 9,500 pounds per aircraft, the Spitfire cost nearly twice as much as a Hawker Hurricane. In June 1936, the Air Ministry ordered 310 Spitfires, fewer than half the number of Hurricanes ordered, reflecting lingering skepticism about the design. Production was delayed by manufacturing complications. The stressed skin construction required precision riveting and compound curves that Supermarine's facilities weren't equipped to produce efficiently. Initial production aircraft didn't reach squadrons until July 1938, 2 years after the prototype flew. But while British procurement officers debated the Spitfire's value, Germany was preparing for war. The Luftwaffe, rebuilt secretly after 1933, possessed the most modern air force in Europe. German fighters, the Messerschmitt Bf 109, were monoplanes with performance comparable to the Spitfire. The Bf 109 entered service in 1937, a year before the Spitfire, giving German pilots critical experience with high-speed monoplane combat, while RAF pilots still flew biplanes. When Germany invaded Poland in September 1939, the Luftwaffe demonstrated what modern air power meant. German fighters established air superiority within days. Polish biplane fighters were slaughtered. The implications for Britain were obvious. Biplane fighters couldn't survive against monoplane opponents. The RAF needed Spitfires and Hurricanes in quantity immediately. But production remained slow. By September 1939, only 9 RAF squadrons operated Spitfires, approximately 180 aircraft total. Hurricane production was faster, equipping 18 squadrons. The remaining 39 fighter squadrons still flew obsolete biplanes. If Germany attacked Britain in 1939, Fighter Command would have faced the Luftwaffe with insufficient modern fighters. The Air Ministry accelerated production frantically. Additional manufacturers contracted to build Spitfires under license. Production techniques were streamlined, sacrificing some refinement for speed. By May 1940, when Germany invaded France and the Low Countries, Fighter Command possessed approximately 400 Spitfires and 600 Hurricanes, barely adequate numbers given anticipated losses. The Battle of France revealed what Britain faced. The Luftwaffe overwhelmed French and British forces through coordinated use of fighters, bombers, and ground attack aircraft. RAF fighters based in France fought desperately but were outnumbered and eventually withdrew to Britain, leaving France to collapse. By June 1940, Britain stood alone. Germany controlled Europe from Norway to Spain. Invasion seemed inevitable. German planning assumed Britain would surrender once the RAF was destroyed. Reichsmarschall Hermann Göring, commanding the Luftwaffe, promised Hitler that German air power would eliminate RAF Fighter Command within weeks, enabling the invasion. The campaign began in July 1940. German strategy was systematic. Destroy RAF fighters on the ground through bombing raids on airfields, force remaining fighters into combat where superior German numbers would achieve attrition, and establish air superiority over the English Channel, enabling invasion. The plan was sound. German intelligence estimated Fighter Command possessed approximately 600 modern fighters against 1,200 German fighters and 1,500 bombers. The numerical advantage seemed overwhelming. But German intelligence failed to understand what the Spitfire represented. Luftwaffe pilots, accustomed to easy victories against Polish and French aircraft, assumed British fighters would be similarly outmatched. The Bf 109 possessed excellent performance, superior to most contemporary fighters. German pilots expected the Spitfire to be inferior, slower, less maneuverable, poorly armed. The first large-scale engagements in August 1940 destroyed those assumptions. Spitfire pilots engaging Bf-109s discovered the British fighter was competitive in every performance category. Maximum speeds were nearly identical, the Spitfire slightly faster at altitudes below 15,000 feet, the Bf-109 faster above. The rate of climb favored the Bf-109 marginally, but in turning combat, the Spitfire possessed a decisive advantage. Lower wing loading and greater wing area enabled tighter turns at all speeds. The tactical implications were critical. German fighters attacking British formations could achieve an initial advantage through diving attacks from superior altitude, but once combat devolved into turning battles, as it always did, Spitfire pilots could outturn Bf-109s, achieving firing positions that German pilots couldn't escape. The result was combat parity despite German numerical superiority. Spitfire armament proved devastating. 8 machine guns concentrated fire into a cone that was nearly impossible to avoid in the confined space of a dogfight. German pilots discovered that a 2-second burst from a Spitfire's guns would disable or destroy a Bf-109. The psychological impact was significant. German fighter pilots, expecting easy victories, found themselves in battles where survival required constant vigilance. The aircraft's structural strength surprised everyone. Spitfires returned from combat with battle damage that looked catastrophic, wings perforated by dozens of bullet holes, fuselages shredded by cannon fire, control surfaces partially shot away. Yet the stressed skin construction distributed loads so effectively that the aircraft remained controllable. Pilots landed aircraft that should have broken apart in flight, testimony to Mitchell's engineering that no one had fully appreciated. But the Spitfire's greatest contribution wasn't technical, it was strategic. The aircraft became the symbol of British resistance. Newspaper photographs showed Spitfires scrambling to intercept German raids. Radio broadcasts described Spitfire pilots fighting outnumbered against German formations. The public, terrified of invasion and desperate for hope, fixated on the graceful fighter as evidence Britain could survive. The Battle of Britain's outcome hinged on mathematics that Fighter Command barely understood. RAF losses averaged 50 fighters per week throughout August and September 1940. Production delivered 40 new aircraft weekly, a deficit of 10 fighters every 7 days. At that attrition rate, Fighter Command would cease to exist by mid-October. Germany would achieve air superiority. Invasion would proceed. But German losses were equally severe. The Luftwaffe lost fighters and bombers faster than German industry could replace them. More critically, experienced pilots were irreplaceable. Training a competent fighter pilot required months. German pilot losses were catastrophic, dozens weekly, killed or captured over Britain, where bailing out meant internment rather than return to service. By late September, Göring recognized the Luftwaffe couldn't sustain the offensive. Fighter Command, though battered, remained operational. RAF fighters continued intercepting German raids. Luftwaffe bomber losses were unsustainable. On September 17th, Hitler postponed Operation Sea Lion, the invasion of Britain, indefinitely. The air battle continued sporadically through October, but never regained the intensity of August and September. Fighter Command's victory was narrow. If the Spitfire had been delayed 1 year, if production had been slower, if performance had been less exceptional, Germany would have achieved air superiority and invaded. The margin between survival and defeat was approximately 200 Spitfires, the difference between adequate numbers to maintain combat effectiveness and insufficient forces to prevent Luftwaffe dominance. But Reginald Mitchell never witnessed the battle his aircraft won. Mitchell died of cancer in June 1937, 3 years before the Battle of Britain. He had completed the Spitfire's basic design but didn't live to see combat results or the modifications that would keep the aircraft competitive through 1945. His final years were spent fighting terminal illness while perfecting details of the aircraft that would save Britain. The irony was absolute. Air Ministry officials who had dismissed Mitchell's design as impractical spent the summer of 1940 desperately pleading for more Spitfires. Production became the highest national priority. Every available manufacturer contracted to build components. Women's workforce participation expanded to compensate for men drafted into military service. By 1941, Spitfire production reached 300 aircraft monthly, triple the 1940 rate, achieved through factory expansions, streamlined manufacturing, and a national commitment to building the fighter that had proven itself in combat. The aircraft evolved rapidly. The Spitfire Mk1 that fought in 1940 was followed by progressively improved variants, the Mk5 with a more powerful Merlin engine and revised armament, the Mk9 with a two-stage supercharger enabling combat at 40,000 feet, and eventually over 20 major variants addressing specific operational requirements. Total production exceeded 20,000 aircraft, more than any other British fighter. The Spitfire's technical influence extended beyond Britain. American fighter design, previously oriented toward heavily armed but slow aircraft, shifted toward emphasizing speed and maneuverability after observing Battle of Britain results. The P-51 Mustang, developed in 1940, incorporated aerodynamic lessons from the Spitfire: thin wings, streamlined fuselage, and laminar flow airfoils, minimizing drag. The Mustang eventually used Rolls-Royce Merlin engines, the same power plant that made the Spitfire effective. Soviet aviation designers studied captured Bf-109s and Spitfires, recognizing that future fighters needed to match German and British performance. The Yakovlev Yak-3, introduced in 1943, reflected direct influence from studying Spitfire aerodynamics and combat tactics. Soviet pilots who flew Spitfires provided to the USSR under Lend-Lease consistently praised its handling and performance. German designers, confronted with evidence that the Spitfire matched or exceeded Bf-109 capabilities, developed improved variants. The Bf-109F and G models incorporated lessons from combat against Spitfires, improved aerodynamics, more powerful engines, and heavier armament. The Focke-Wulf FW-190, introduced in 1941, represented Germany's attempt to create a fighter superior to the Spitfire in all categories. For a period in 1941-42, the FW-190 was superior, forcing Britain to develop the Spitfire Mk9 to restore parity. This cycle, incremental improvements driven by combat experience and enemy capabilities, defined fighter development throughout the war. The Spitfire that entered service in 1938 bore only superficial resemblance to the Spitfire Mk14 operating in 1945. Engine power had doubled, maximum speed increased from 360 miles per hour to 450 miles per hour, and armament evolved from 8 machine guns to 4 20mm cannons. Yet the fundamental design, elliptical wings, stressed skin construction, and Merlin engine remained unchanged, testament to Mitchell's original concept. The pilots who flew Spitfires developed extraordinary affection for the aircraft. Letters, diaries, and post-war memoirs consistently described the Spitfire as the most responsive and forgiving fighter of the war. Unlike some high-performance aircraft that punished pilot errors harshly, the Spitfire remained controllable even when mishandled. Novice pilots could survive combat long enough to gain experience. Veteran pilots exploited the aircraft's capabilities to achieve combat effectiveness far exceeding their opponents. The aircraft's elliptical wings, initially criticized as expensive to manufacture, proved essential to combat performance. The wing shape distributed lift optimally, enabling tight turns without tip stalling, a phenomenon where wing tips lose lift before the center, causing uncontrollable rolling. Conventional tapered wings suffered tip stalling at high angles of attack, limiting turning performance. The Spitfire's elliptical design maintained lift across the entire wingspan, enabling turns that would stall other fighters. This single characteristic, the ability to turn tighter than opponents, saved countless pilots. In combat, the fighter that could turn inside its opponent gained firing position. Spitfire pilots could force German fighters into defensive maneuvers, achieving kills or forcing opponents to break off engagement. The tactical advantage was decisive in the swirling dogfights common during 1940 to 1941. But the cost of the Battle of Britain extended beyond aircraft. Fighter Command lost 544 pilots killed during July to October 1940, approximately 1/4 of available fighter pilots. The majority died in aircraft other than Spitfires. Hurricane pilots suffered higher casualties due to that aircraft's inferior performance, but Spitfire losses were significant. Every Spitfire squadron lost pilots weekly, the attrition grinding down even experienced units. Replacement pilots arrived with minimal training, sometimes less than 10 hours in Spitfires before being thrown into combat. Survival rates for novice pilots were appalling, approximately 50% casualties within their first 5 combat sorties. The Spitfire's forgiving handling characteristics helped, but no aircraft could compensate for inexperience against veteran German pilots. Ground crews worked 20-hour days maintaining and repairing aircraft. Battle-damaged Spitfires required extensive work, patching bullet holes, replacing damaged components, and realigning control surfaces. Crews developed extraordinary efficiency, often returning severely damaged aircraft to operational status within days. Their contribution was invisible to the public, but essential to sustaining combat operations. The British public, watching fighter contrails mark the sky during daily raids, developed an emotional attachment to the Spitfire that transcended rational assessment. The aircraft became a symbol of resistance, defiance, and ultimately survival. War bond campaigns featured Spitfires. Donations funded entire squadrons. Communities raised money to buy Spitfires bearing their names. The aircraft's cultural significance matched its tactical importance. The officers who had dismissed Mitchell's design in 1934 never publicly acknowledged their error. Air Ministry files contain no apologies, no admissions that procurement decisions had nearly left Britain defenseless. Post-war histories credit visionary leadership for Spitfire development, omitting the resistance Mitchell faced and the years wasted debating whether monoplane fighters were necessary. Mitchell's role was gradually forgotten by the public, though engineers and pilots remembered. Supermarine's design team, continuing Mitchell's work after his death, developed every Spitfire variant using principles he established. The aircraft's longevity, operational service from 1938 to 1955, reflected the fundamental soundness of Mitchell's original concept. The designer, who was mocked as impractical, created an aircraft that served longer than any fighter of its generation. The design dismissed as too radical became the standard against which all other fighters were judged. And the aircraft procurement officers insisted was too expensive, proved invaluable when national survival depended on its capabilities. The final Spitfire was delivered in February 1948. Production ceased not because the design was obsolete, but because jet fighters had rendered propeller-driven aircraft obsolete. The Spitfire's performance ceiling, improvements limited by propeller efficiency and piston engine power, had been reached. Future fighters would be jets, fundamentally different aircraft pursuing performance through different technologies. But the Spitfire's legacy extended beyond technical specifications. The aircraft demonstrated that aerodynamic refinement and engineering excellence could create decisive tactical advantages. It proved that investing in superior designs justified higher costs, and it validated the principle that technical innovation, pursued despite institutional resistance, could determine strategic outcomes. Modern air forces operate jets incomparably more capable than the Spitfire. But the principles Mitchell established, minimize drag, maximize power-to-weight ratio, optimize controls for pilot effectiveness, remain foundational to fighter design. The F-16, F-22, and every contemporary fighter reflect doctrines first demonstrated by the aircraft that Air Ministry officials dismissed as impractical. In museums today, Spitfires sit on display, their elliptical wings and graceful lines still beautiful 80 years after their first flight. Visitors photograph the iconic shape without understanding the desperation that drove its development or the skepticism it overcame. Museum placards describe Battle of Britain victories without explaining how close Britain came to having too few Spitfires to matter. The officers who laughed at Mitchell's design spent August 1940 begging for more Spitfires, frantically accelerating production of the aircraft they'd nearly rejected. The designer mocked as a dreamer but built the weapon that saved Britain. And the fighter dismissed as too radical became the symbol of British survival, the aircraft that proved technical excellence could defeat numerical superiority. Reginald Mitchell died believing his aircraft might never reach squadrons in meaningful numbers, never knowing it would become the most famous fighter in aviation history. The Spitfire he created outlasted him by 18 years of operational service, fought across every theater, and influenced fighter design worldwide. The laughter stopped on August 15, 1940, when Spitfires tore through German formations over Kent and proved that the impractical dreamer had been right all along. Sometimes the aircraft they mock becomes the weapon that saves them. Sometimes the designer they dismiss creates the machine that changes everything. The Spitfire that Air Ministry officials nearly rejected became the fighter that Britain begged for, the only aircraft that could win the battle that mattered. The mockery faded, the machine remained, and Britain survived because one designer refused to accept that excellence was impractical.